in your notes packet, you have this data table. Go open your notes packet to this page called Molecular Geometry. So you're going to have to memorize this chart, and I'm just telling you that right now. So make a note, memorize. Now that you know how to draw Lewis structures, there are shapes that they have. In your lab that you're starting today, you're going to be building 3D models of all of these. But these are not every shape that exists, just some of the most common ones that you'll see. And you will have to know these shapes. And so how do we read this chart? These are the geometry names. So something can be linear, trigonal, planar, bent, or angular. You can call it bent, you can call it angular, you don't say both. Tetrahedral, trigonal pyramidal, bent, trigonal bipyramidal, octahedral. And you can figure out what shape something has by looking at these two columns. So how many atoms are bonded to the center atom, and how many lone pairs of electrons there are. This should say on the center atom. Honestly, I don't even pay attention to these two columns. They don't help. And then here are some examples of how they look and actually how you're going to be drawing them. And so get out your practice packet to page 3. We're going to use this chart to identify some of the names and shapes of these molecules that you've already drawn. Okay. So looking at your practice packet, page 3, number 1, you should have already drawn SiBr4, and it should look like this. And so if I want to figure out what shape this has, I go to my chart. How many atoms are bonded to the center atom? My center atom is silicone. It has 4 atoms bonded to it. So I'm going to go down to where the 4 is. And then how many lone pairs are on the center atom? My center atom has no lone pairs. There's no dots around it. So 0. 4, 0. This is called a tetrahedral. So if I asked you what geometry does SiBr4 have, you would say it's a tetrahedral, because it has 4 atoms bonded to the center and 0 lone pairs. And then mine is actually drawn correct. When you have something that's a tetrahedral, you have to draw it in this shape, which mine is already drawn like that, so that would be correct. But let's say you had drawn SiBr4 like, I don't know, this. You would need to go ahead and redraw it, because that's not correct. I want it drawn like this. Okay, let's look at number 2, BrF5. You should have drawn this one. So bromine has how many atoms bonded to the center? It has 5 atoms bonded to the center. And how many lone pairs on the center atom? It has 1 lone pair on the center atom. When I go to my table, though, I see trigonal bipyramidal has 5 atoms bonded to the center, but 0 lone pairs. And I don't see anything else with 5 atoms bonded to the center. So guess what? This has a geometry that's not on our list. That's okay. I wouldn't ask you the geometry of this one on the test, because it's not one that you have to know. But there will be some examples in the lab that there's a few that don't have a shape on our list, like this one doesn't. And so if I asked you the name of the geometry, you would not write trigonal bipyramidal, because it's not that. A trigonal bipyramidal has 5 things attached and 0 lone pairs. You would just leave it blank. Okay. Let's look at a few more. Number 4. 4 things attached to the center and 0 lone pairs on the center. So, sorry, it's number 3, not number 4. So it's got 4 things attached, 0 on the center. That's a tetrahedral. and my tetrahedral is drawn correct. Number 4, BeH2. Okay. It's got 2 atoms attached to the center, one hydrogen, and then it has no lone pairs on the center. So there's no dots around beryllium. So this is a 2, 0. It is a linear, and it should be drawn like this. Mine is drawn like that. If you drew it like this, that's also fine, but they need to be linear, which means that they are 180 degrees apart from one another. So the reason why molecules take these shape, this is what they actually look like 3D-wise, is because if you remember, these bonds are electrons. Electrons are negatively charged. So they want to be as far apart from each other as possible. And that's why they take on these shapes. So number 4, a linear, when there's two atoms bonded and no lone pairs, they are as far apart as they can get. They're 180 degrees apart. They can't get any more far apart than that. But let's look at number 5, H2S. Sulfur has 2 atoms bonded to the center, but it has 2 lone pairs on it. And so it is not a linear, it is a bent. And the way that we draw bent is like this. So I would actually need to go redraw mine. And these, and you'll see when you build them today, they bend down because you have lone pairs right here. These lone pairs are electrons. They're negatively charged. So these negatively charged things repel these chemical bonds that are also negatively charged. So this is how they kind of escape each other. And then let's look at number 9, because that's a shape we haven't done yet. H2CO. The carbon has 3. Now, it has a double bond, but this says how many atoms are bonded to the center, not how many bonds there are. There are 3 atoms bonded to the center. And so it could be this one or this one. And then it has no lone pairs on the center. 3, 0, it's this one. It is a trigonal planar. And it should be drawn like this. So I'm going to actually have to flip mine. See, and it doesn't matter which ones you put up top, but this is how it should look. 2 up, it makes a Y, 1 down. And so that's reading your geometry chart. Again, yeah, you have to know these shapes. If you actually take the time in the lab and you build these shapes with your modeling kits, you'll be fine. You'll learn really fast what they look like. And it's pretty cool because it makes these 2D things come to life.